These are lab balances. Basically, this would be considered an analytical lab balance, so it's a bit more, way more precise and accurate. And then this is kind of a more standard balance. They're all more or less the same in terms of use and function. And they've got a shield of some kind to keep the sample that you're trying to get the mass of from being affected by things like stray air currents, wind, that type of thing, because that'll mess with your readings, especially on something that's really precise. So you've got your shield, you've got the platform inside the balance. So I'll go ahead and remove my janky little shield here, and basically the platform is where you'll place your sample to get the mass. Here's what the platform looks like on this small guy. So this one is double shielded because this is what would be referred to as a microbalance, and this thing can actually go to the microgram, which is 1/1,000,000th of a gram, and it's only got a 22 gram capacity, but that's super impressive. This actually should be vibrationally isolated on like a granite table. Maybe you could get away with just a granite slab, but this isn't set up properly to be able to take readings at that level. I just have it for playing around here, but really if I wanted to go down to the microgram, I would really need to do a better job of setting this guy up. But this one just goes to the thousandth of a gram, 1 milligram, and it works great with this setup. I have it on a small granite slab just to make it easier to level. So we've got the shield, we've got the shield, we've got the sample tray, we've got the display readout. Most modern balances, past 10 years or newer, maybe even 15 years at this point, getting kind of old, are gonna have like a nice digital display, make it real easy to read. And then the last piece that you should be aware of is the leveling indicator. So this little bubble, I don't know if you can see it. Yeah, there we go. So every balance is going to have, that one is over there, a level indicator, and it's basically to make sure that your balance is level, because if it's not, it's going to give you wacky mass readings that are always off, essentially. So that's something to check right away if things are going wrong, or if it's a balance that you haven't used before. If it's a new setup, definitely check that it's level, because if it's not, then you can't really trust your numbers anymore. And yeah, so those are the main components of the balance. So here's the display of the microbalance, kind of a close-up of it, just to go through some of the general functions that you would see on most balances. So two really important ones that are going to be in your general use case is tare and zero. So a zeroing the balance means you have nothing at all on the sample plate, and you tell the balance, okay, that's the 0 point. There's no mass. When you're tearing, you have, for instance, something like a weigh boat on your sample tray, and you don't have any sample in there, but you want to only have the number of the sample that you're going to put into your weigh boat. And so you put the weigh boat on the sample tray like so. And now you have, you know, some number that corresponds to how much your weigh boat is. Now this thing is taking some time to stabilize because it's so dang precise. Anyway, so you have this weigh boat on there, but you only care about the sample weight itself. So you can tare your sample, and here, this is interesting actually, because this balance actually just has the re-zero option. So it treats tare and zero by the same button, which can be misleading. But anyway, so you hit this re-zero, and okay, that was relatively quick. So now this is your new zero, but obviously you've taken up a little bit of this capacity. This is a capacity indicator of how much of your overall capacity you've used up. So now you can weigh your sample, whatever that is, without worrying about your sample boat weight. Okay, so this is a more kind of standard, what you would expect to see on a balance. I'm just going to remove this. I really need to like 3D print a more proper shield. So now I place the boat on there, I tare it, there we go. I'm ready to put my sample in the weighing boat. As far as some of the do's and don'ts, one of the things that you don't want to do is, you know, blow powder, or sorry, you don't want to leave powder on your sample tray, and you don't, if you have powder, you don't want to just blow it off with your mouth, because you can, you know, deposit moisture and stuff, and then it'll throw off your readings because the water can evaporate and so on and so forth. It's probably wouldn't be as big of a deal on a balance like this because it's only to the milligram, but on that other guy, that would make a huge difference. You could probably watch in real time the mass change as water droplets evaporate. So something that can be really useful is one of these little blowers that you can use to just kind of clean off the platform. And it's not as big of a deal if you have stuff around the platform, but on the platform itself, you really want to make sure you don't have any loose powders or anything like that on there, because if you're going from sample to sample weighing things, especially with a weigh boat or something, you can drag that powder off and it'll throw off your future readings, like if you're doing a bunch of readings, you know, all in series. Another thing that you want to make sure you do is when you are weighing something, you always want to have that shield in place, so that way the you know, stray air currents and stuff like that in the room won't affect your reading. Again, you know, on a balance like this, it's probably not going to matter too much for me, especially in a room like this. I don't have much air movement here. But on that micro balance, it makes a huge difference. That's why it's double shielded even. It's, you can, let's see if I can show you. You've got two draft shields. So you've got an outside one and an inside one to really make sure that, see, this is the inside one, that you get rid of any potential stray air currents. Okay, another thing that can be useful is, well, it can be very useful if you are having reading issue or stabilizing issues or repeatability issues. You can calibrate the balance, and most balances will come with an internal calibration standard of, I don't know, whatever it is. This one probably has like 100 grams in there. That other one is probably 10 or 20 grams, or they'll have multiples, but they can internally calibrate themselves, and a lot of them have an automatic calibration that they'll do, every 24 hours or something. Especially because if temperature is changing, you want to make sure that you're doing calibrations consistently. And so it's very easy. It'll be something along the lines of, adjust internal, there's an adjust external. That means you're using your own weights, your own calibration masses. If you're just starting out, you're new in a lab, whatever, something like that, I wouldn't mess with doing an external calibration yourself just yet until you get some experience with playing with balances. But definitely, by all means, if something's looking weird, go ahead and do the internal adjustment, because all you have to do is you just press the button and it does everything for you. So you really don't need any experience aside from before you do the internal adjustment. Just make sure that the balance is level. So use that level indicator and make sure that it's actually level by turning the feet before you do the calibration, because the last thing you want to do is you calibrate it when it's off leveled, and someone later comes in, sees it's not level, they re-level it. It probably wouldn't be that big of a deal, because if someone's going to re-level it, they're going to also recalibrate it, but just make sure it's level before you calibrate. Yeah, that's just a kind of quick introduction to analytical lab balances. Hopefully this helps somebody. I know for a lot of people this is kind of very something they don't even think about in the lab anymore, because they've just done it for so long and balances are an everyday thing. But if you're new, you've never used the balance really rigorously, then it's good to have an intro. Hopefully this helps somebody.